open on your notes. This is where we left off yesterday, and we will start here today.
Honey, I turned your right.
Okay. So the Adobe scan, we're gonna do at the end. There's something weird with my volume. I can't show a video and use the smartboard because I don't have volume then. So because of that, we're gonna do it at the end so I don't screw up my volume. Okay, so we are gonna do, just so you guys kind of know, we are going to do basically 3 pages today. This is just that sheet. So basically we're doing this page, and this page, but it's all new. And so I would really pay attention and take good notes, okay? I also want to show you, because we have somebody that just came back to class. So I want to show you guys just one more time, as long as I have stuff in here. When you go to Schoology, you're going to open our class, okay? And then right now we're in chapter 4. Say like I got one person quarantined yesterday, and then I think like 5 today. So God forbid that happened to you. I need you to know where things are, okay? You have to, again, join my team meeting if you don't want to be marked absent. If you're sick, that's different, but let us know that you're sick. You can't just not show up to class. You know, a parent can call the office. They could send me a message. You could send me a message, whatever. But if you ever want to print your notes and you're at home, so this was yesterday's notes that are there, and you could print that off, okay? Completed notes, so if you didn't take notes during class, you want to look back at something, this would be what I did yesterday, and it has all of my notes. Okay, so you can always do that. It also has my videos, so like yesterday's video, so Brooke, this is what you would do for that. Just go to videos here, and the reason there's 2 videos here for yesterday is I do one video before lunch, one video after lunch. So Brooke, you'd have to watch both of these, okay? So each day there's usually going to be 2 videos for each day. And then assignments is here. And I just want to tell you, the picture assignment I pushed out to tomorrow night at midnight because I keep changing how we're going to do it. This was that worksheet from yesterday. How did you guys do on that? Did you have questions on it at all? You were okay? Did you see I sent you a key too, so you could check it? Okay. And then this is today's assignment here, okay? So you would just go in there and submit, okay? So Mason, you're leaving today. That's how you can access stuff. When you get done tonight, my stuff should be there. Okay, so let's go back to my notes here. And like I said, we're gonna learn some new types of factoring today. So first I'm gonna just show you this. This is actually the next page, but I'm gonna move it back one, okay? Today what we're gonna do, or I should show you, yesterday we reviewed 2, and we reviewed this, difference of squares, sum of squares. We reviewed that. We reviewed 3 terms, factor, and is it a general trinomial? And then we reviewed for 4 things. We've reviewed factoring, factor out a greatest common factor, and then factor by grouping for 4 things, okay? Today, what we are going to be learning is sum of 2 cubes, difference of 2 cubes, and factor by grouping with 6 terms. Okay, and like I said yesterday, a lot of times you think you just got done factoring, but you're not done. So we'll talk about that too, okay? So let's go to this page, and we're gonna learn something called sum and difference of cubes, okay? First of all, with sum and difference of cubes, you have to be good at knowing the different cubes. And as you do this a while, you will know them. Yesterday, I gave you a cheat sheet with this on it. And if you turn this around, it has the sum of cubes and the perfect squares and the perfect cubes on the back of it. So if you look at that sheet, you do have those values, okay? So with sum and difference of cubes, you have to have where this term is a cube as well as this term is a cube, okay? It can either be plus or minus, and whether it's plus or minus tells us which formula to use up here, okay? The first step of all factoring, no matter what, is always for you to do the greatest common factor. So do you guys see anything that I could take out of this first? An X? And is there something else? If they're both even, what for sure can you take out? 2. So let's try 2x.
Wait, can you take out 8 of each?
8 does not go into 54.
Oh,
9 does, but not 8. Okay? So I would look at then 2x times what gives me 16x to the 4th. Do you get 8x to the 3rd? Okay. And then plus 2 times what is 54? 27. And we already got our x, so we would need y to the 3rd. Okay. Now, when you are doing difference of cubes or sum of cubes, 2 things have to happen, okay? One is your numbers have to be perfect cubes. How do you know that? You look at this. Notice 8 is a super common perfect cube. 27 is a super common perfect cube. Your variables have to be to a power that is either 3, 6, or 9. In fact, I don't even think they'd ever give you 9. They'd either give you 3 or 6, okay? So here we have, and the plus or minus doesn't matter. Either one works. It just, if it's plus, that means you're using this formula, okay? So here's what we would do here. I'm going to kind of just keep bringing down this 2x, but I'm going to leave it out front. But here's what we do. We call A, just so we can put it into that formula, we say, what is A? And A would be what here is cubed, okay? So you're kind of asking yourself, what cubed gives you 8? And that is 2, right? And then what cubed would give you x cubed? Wouldn't it be x? Do you get that? So this is like, what cubed would give me this? It's like taking the cubed root too, but I usually just ask myself, what cubed would give me 8? That's 2 cubed. What cubed would give me x to the 3rd? That's x. Then I call B, what cubed would give me this? What cubed would give me 27? 3. And then what about the variable? Y. Okay? Now, as you get good at this, you're probably not going to do this, but we are for this time. Do you see how this one's a plus? We are going to copy down this formula. Okay? It's a plus b times a squared. And notice these 2 signs are opposite. Okay? This is plus, the middle term is minus. And then here you just multiply these two together, plus here you square that. So it's a plus b times a squared minus ab plus b squared. Once you get good at this, you probably won't write that down, but you certainly could. Now what we're going to do is just put 2x in everywhere we see an a, and we're going to put 3y in everywhere we see a b. So still have that 2x. A is 2x, b is 3y. Now, a squared, think about this, guys. What is 2x squared? 2 squared is 4, and then x squared, right? So 4x squared minus a times b. 2 times 3 is 6, and then xy. So I always just multiply these two together in that middle term. Whatever sign this is, this one's opposite it, okay? And then it's plus b squared, which is 3y. What's 3y squared? 9y squared. Now, the nice thing about sum of cubes and difference of cubes, this can never be factored more. So once you get down to this, you can just leave it. It can't be factored. Okay, so this would be our answer here. This one, you would think it could be like a trinomial factoring, but it never can. Okay, good question. All right, now again, we have two terms. Are our variables okay for it to be sum of cubes? They are, right? Because they're both cubed, which is what we want. Is 8 a perfect cube? Yes. Is 5 a perfect cube? No. That means we can't do this, and all you have to write then is prime. Okay, what if that 5 were 125?
Yes.
Then it could, then you'd have to factor it. So not many of them are like this, you guys, but you're gonna like the ones that are. Okay, first thing we always do is look at, could I factor something out? What could I factor out of this? A w? And a way you can kind of cheat, you guys, to see like, maybe I could, maybe I wouldn't. 64 is a perfect cube. 125 is a perfect cube. So that kind of tells you probably we can't, okay? 8 doesn't go into 125, okay? So here's what we're gonna do. W times what gives me that? It's 64 W cubed, okay? W times what gives me that? It's 125 Z to the third, okay? That W just kind of hangs out in front there, and we just keep kind of copying it down. But I always do the A equals and the B equals, okay? So I asked myself, what cubed would give me this, okay? What cubed gives us 64? 4. And then it would be just W, correct? Everybody get that? What cubed gives me 125? 5. And then what variable would I use? Z, okay? Now, just because you guys are first starting, I am going to again copy the formula. This time we have a minus sign. So I am going to take this. So this is the problem. This is what I copied down. A minus B times A squared plus A times B plus B squared. Notice these two are opposite signs, okay? So it's A minus B times A squared plus a times b plus b squared. Okay, then I'm just going to substitute in. A is 4w, b is 5z, a squared. What's 4w squared?
16W.
Very good, 16w squared. Now, in the middle, we just multiply these two. What would you get when you go 4w, 20wz? Very good. Plus b squared. What's 5z squared? 25z squared. You don't have to write this down, by the way. That's just to help you see it. Okay, now, again, once you do that sum or difference of cubes, this can't be factored. You just have to, I mean, you could try and see, but it won't be able to be factored, okay? And then this is down enough, this is good, so that is factored. Yeah? Okay. All right, let's go to this one. Do you guys see anything, number or variable wise, that I could pull out from? A y and a 5. Good. 5y times what would give me 5y to the 4th? Y to the 3rd. Minus 5 times what gives me 320? You'd have to go 320 divided by 5. Is it 64? Thank you. Okay. And then my y is already out here. So do you guys get that this would just be z to the 3rd? Okay. Now we have to determine, is this sum of cubes or difference of cubes? It's a subtraction, so it would be difference. My variables are both to the power 3, so that's cubes, right? 1 is a perfect square and a perfect cube, so that's good. Is 64?
Yeah.
64 is here, and it's 4 cubed, okay? So this works. So again, I would say A is what? B is what? What cubed gives us y cubed? Isn't it just y, right? What number cubed is 64? 4. And then what would I need for a variable? Z, okay? Now notice that this is difference of cubes. So difference, you're going to use this, okay? A minus b times a squared plus ab plus b squared. So I carry down that 5y. I can't forget about that. A minus b times a squared plus ab plus b squared. And then I just substitute in. So I have my 5y. A is y. B is 4z. A squared would be y squared. Plus a times b is going to be y times 4z. And usually when you do that, you guys, you put your letters in alphabetical order. So instead of saying zy, you would say yz. This one worked out that way, but just so you know. And then plus, what is 4z squared?
16z squared.
16z squared. Good. All right. So now you just have to trust me. This can't be factored anymore. So we're good. And then these two are both to the power 1. So those are good also. Okay. And it's only when you do sum or difference of cubes that you don't have to check if this can be factored more. Okay, so it's not every trinomial, it's just when you do sum or difference of cubes. So how bad was that one? Not bad? Okay. So now what we are going to do is we are going to start doing factor by grouping with 6 terms. Okay? It's the same idea as what we did yesterday with 4 terms, same idea. But what's going to happen is a lot of times you factor by grouping with the 6 terms, and then you have to take things further, okay? Here's another thing. When we did factor by grouping with 4 terms, they were always in the correct spots so that these 2 would be together and these 2 would be together, and we didn't have to rearrange at all. This time, we have to rearrange, which is a pain, okay? So here's how you look at, are they in the correct spot right now, or do I have to move things? What you look at is which 2 are the same. And when you first look at those, you see I have 2x squared. Why don't I just add them together? Because that makes sense. That's what we always do. However, when you have 6 terms and you try to do factor by grouping, you need an even number of things. So you can't add those together. Here's how you can tell which one should go with which. Do you see over here, I have a 28 and a 40. Which one would look better with that, a 4 or a 10? And here's what I'm asking. Does 4 go into both of these?
Yes.
Yes. Does 10 go into both of these? No. So do you get, if we switched these around, my 4 would be here, and 4 goes into each of these, and then my 10's over there, which would be okay. So that's what you ask yourself. Which one would go better with these 2? So let's rewrite that, switching those 2. So I'm going to have the plus 10x squared first, the minus 4x squared second, minus 28x minus 40, okay? So when we had 4 terms, we had 2 groups of 2. When you have 6 terms, you have 2 groups of 3. So these 3 go together, and these 3 go together. But we do it the same way. We look at this and we ask ourselves, what can we factor out of this? What's something that goes into all of those?
X squared.
X squared, perfect. And you look at x squared times what would give me x to the 4th? X squared. Plus x squared times what gives me 7x cubed? Very good. X squared times what gives me 10x squared? 10. Very good. Now, do you guys know if you get this on the left, if you rearrange these correctly, shouldn't this be on the right also? Okay, so we're going to check. And here's my deal here. Yesterday I was saying if the 3rd term is ever negative, I know this is going to be a minus, but I cheat on those and I copy this over here. So today it would be if the 4th term is ever negative. I don't like to deal with negatives if I could. So I put a minus there, and then what I do is put x squared plus 7x plus 10 here, and I see if I can get that to work. Okay?
Show us how to do one with positive and go forward.
Then it's easier. Then you can just look at this and say, what goes into each of these?
Aren't you going to get the same answer as the in parentheses?
Yes, but with positive, you'd always, like in this case, if all these were, if this was plus, wouldn't you take out a 4x, right? But when it's negative 4x squared, you wouldn't know, should I take out a negative 4 or should I take out a positive 4? So that's why I cheat and do this, so I can look at what 4 should I have. Should I have a minus 4 or a positive 4? So here, I'm going to try taking out a minus 4. To check that, is negative 4 times x squared negative 4x squared? Is negative 4 times 7x negative 28x? Is negative 4 times 10 negative 40? Yes. Now, yesterday we did factor by grouping, and we talked about these 2 have to be the same. if they are not the same, you guys, it doesn't mean you did something wrong. It means you didn't rearrange your terms correctly. So you'd have to go back to the problem and see which ones do I have to move.
I have to go also, do you want this in paper or school only?
Schoology, yeah. Yep, so take a picture and put it on there. Okay, so these two have to be the same. If they're not, go back to the original problem. You might have to move around a little. Usually you only have to move 2 things, okay? That's it. So we're gonna write down x squared plus 7x plus 10. We're gonna write that down once. And then for our second term, you guys, we're gonna write this minus this, okay? So x squared minus 4. All right, ladies in the back, you need to not be talking, okay? All right, so as I was saying, we just completed, or we did factor by grouping with 6 terms. And you guys are like, good, we're done, but we're not done, okay? When you have 3 terms, do you guys remember from yesterday? That's when we do like the, I don't even know if I have that on here. We can go back. 3 terms is when you look at factoring into 2 binomials and you look at these rules, okay? So, and then the other one is 2 terms, wasn't it? And this is a square, so we're gonna have to check, can we do difference of squares there? Okay, so let's deal with this one first. This is a trinomial. When it's a trinomial, you put down your 2 parentheses. If this is a plus plus, looking at this here, the plus plus, we should be using 2 plus signs in our parentheses, okay? So if I go back here, I have 2 plus signs here. Now, this is x squared. What do I put here and here?
Okay.
X and x. Now, do you guys remember yesterday we think about what 2 numbers multiply to give you 10? So we want 2 numbers that multiply to give you 10 and add to give us a positive 7. 5 and 2, yes. 5 times 2 is 10, and 5 plus 2 is 7. The 10 is here, that's what you want them to multiply to. The 7 is here, that's what you want them to add to. So we would go 5 in 2. Now, that is factored. If you weren't sure, I showed you yesterday you could multiply this. This is 5x, this is 2x, add them together and you should get that middle term, which we did. So that's factored. Is this that we just did, these 2 parentheses, are these done? How do you know that? Yeah, it's just an x, so you're good. Once you get them down to an x, you can't factor anymore. Now, is this difference of squares? Here's the rules. Difference of squares has to be a minus. Your variables have to be to an even power. 2, 4, 6, 8. And your numbers have to be perfect squares. And here's the perfect squares. And I think you all know 2 squared is 4. So that's a perfect square. With difference of squares, do you guys remember what the signs are? Plus and minus. If that's x squared, what do I put here and here? What do I do if that's a 4? What do I put here and here? 2 and 2. It's like the square root of 4. And the square root of 4 is 2 and 2. Are these done? Because they have just an x, they're done. So now what I'm going to do is that. Okay? Now let's go to this one. Again, what you need to figure out is this in the correct order? Okay? So you want to look at which one do you have on there twice? And Again, we have our x squareds, okay? We can't just combine them together because then we have 5 terms and we have no way to factor that. So what we would do here is look at, does 5 go into 18 and 30? No. Is there something in 12 that would go into also into 18 and 30? Yes. So I'm going to switch these two around. But here's the deal, you guys. Also, on this side, I want it to be where my highest power of x is first, then my x, and then my constant. So here's what I'm going to actually do. I'm just going to take this negative 5x squared and I'm going to put it right there. Then what's going to happen, what I'd have left, because then this is gone, right? I have a 12x squared, then an x, then a number. So they should go down in decreasing order. And if I put this one here, I have an x squared. So it goes x to the 4th, x to the 3rd, x squared. So I'm going to rewrite that, moving just that one. So I'm moving negative 5x squared here.
Why did we move 5x squared right there?
Because the 12x squared went better with these two.
Okay.
And the x squareds are going to come after an x to the 3rd. So it goes, you know how it goes x to the 4th, x to the 3rd, you'd have an x to the 2nd. And then of these 3 left, notice you have x squared, then x, then your number, which is what you want. Okay? All right, now we have plus 12x squared minus 18x minus 30. Okay? Now we have 6 terms. We split them into 2 groups of 3. So I'm going to factor this in one group, this in one group. Okay? Do you guys see something I could take out of this? X squared, good. And then you ask yourself, x squared times what gives you 2x to the 4th? 2x to the 2nd. X squared times what gives you negative 3x to the 3rd? Okay. X squared times what gives me negative 5x squared? Negative 5. Okay. Now let's look at this second one. Do you guys see something that goes into all 3 of these? 6. Okay. So it'd be 2x squared. 6 times 2x squared is 12x squared. 6 times what is negative 18x minus 3x. 6 times what gives me negative 30 minus 5.
You really could just copy it down.
Yes.
And then figure out the number. That's-
Yeah, you're right. You're right. Now, do you guys see that this and this are the same? Okay. So we write that down one time. 2x squared minus 3x minus 5. And what's left over? X squared plus 6. Okay. If I look at this, I have to try to factor it. It's a trinomial. It's the middle of your chart, that like flow chart. And that is the one where we try the 2 sets of parentheses. If this is minus minus, that means it's this bottom one, where one is going to be plus and one is going to be minus. And it's, you can switch those. There's nothing saying that the first one has to be plus and the second one has to be minus. Okay? Now, I have x squared, so I put x and x. Do you get it if you have 2? You could just put a 2 here and a 1 here. Is that our lunch? Okay. All right, guys. We'll continue after.
It's fine.